Hi guys, this is Rohit Ghosh, and I'll be the one who would be the instructor for your next, I don't know, probably 18-20 lectures. So today is the first day of descriptive stats, and this is my first lecture with you guys. And hopefully, I'll be the one who's, hopefully I'm gonna be helpful through the rest of your journeys. So today we are going to be talking about descriptive stats, and after that we are going to talk about inferential stats. Then we are going to talk about entire module of machine learning, and I'm going to be the one who's going to just talk and talk. I hope you like my videos, and I hope you kind of get accustomed to the way I'm kind of explaining things, and hope that's helpful to you. That's the most important thing. Obviously, if you are not kind of getting it, if you are kind of also enrolled for the physical program that is there, so you definitely can ask your instructor at any point in time that you don't get any part of the lecture. If you are doing the self-paced course, well, you can obviously Google out things and probably watch my videos at a lower speed to kind of get the entire context of what I'm saying. But that's about it. There's nothing more to kind of talk at my end, and I sadly can't talk to you at this point in time. But definitely let's get started. And today what we are going to do is the first lecture is that we are going to talk about summarizing data in descriptive stats. So descriptive statistic is basically the statistics of describing your data, right? And this is slightly different from the statistics of inferring your data, inferring whatever you want to infer from your data, right? So that is inferential stats. This is descriptive stats, and descriptive stats is majorly concerning about this, kind of explaining how your data looks like, and that's about it. So nothing in here. It's a very easy course, very easy entire thing. Not only descriptive, inferential stats, everything that is going to come up after this around machine learning and everything that is going to come up is going to be extremely easy, right, for you guys. Just understand your basics, and if you don't understand at any point in time, just stop there. Probably just go back and again replay the entire lecture, and you should be fine with it. So now summarizing your data. So as of now, you just can forget about the word cloud. That's not important. Program so far, we have learned about Python basics. We have learned about functions, object-oriented programming in Python, NumPy, pandas, and data visualization. Now, the important part, if you don't get the basics of Python correct still now, well, I would recommend don't go ahead and jump into this course. It's probably a good idea to take a break right now, go back to your Python, pandas, be very clear with them, be absolutely sure you understand that, because if you don't understand that, well, a lot of those probably today and the lecture after this, inferential stats, so descriptive and inferential stats, you may still get through, but linear regression onwards, it's going to be extremely painful if you don't understand pandas or Python, because lectures today and the next one are more mathematical and statistic based. It's easy and extremely intuitive to understand probably, but once you kind of go ahead of that, it's going to be a tough win. So I would suggest probably, take a break right now, and if you're not very comfortable about your Python skills, if you're confident, well, let's get started. There's nothing stopping us right now then. So agenda for the day is we are going to talk about the statistical measures: mean, median, spread, range, interquartile range, mode, variance, correlation, and causation. So that's the idea. So meet John Doe. He may not be from Earth, but still, well, let's not get into John Doe's description. It seems that John Doe has a massive decision to move to New York City. John Doe is like any one of us, like you, me, anyone from here. And he's determined to buy a house with his savings and ready to settle in the Big Apple, the New York. He's been in love with Brooklyn ever since he visited in 2003 as a college kid, but he's been looking for a good house in Brooklyn, New York. And Brooklyn, New York, if you have been there, you probably know that it's a really goddamn expensive place to be in, right? So notice that Brooklyn is one of the 5 neighborhoods or the 5 boroughs of New York. And John Doe does some research while he sits back in his temporary rented apartment and gets a list of 1,460 houses. That's quite a lot of houses, huh? 1,500 houses. So now let's have a look at this 15 of these so-called houses, right? So what we are doing is John Doe has collected this New York database of houses. I don't know, John Doe seems like a very dicey guy. I really do trust him, but some way he has kind of come up with 1,500 examples. They're looking at the top 15 of them, and we see the prices, and the prices look haywire. They look absolutely all over the place, right? So Well, obviously, right, prices are ranging from $120,000 to some are over $200,000. Now, if for a sane person, he has to kind of plan for the fund that he needs to observe, he needs to allot to kind of buying houses. It's impossible, right? So obviously, if if you have been to NYC, you know how expensive it is just to survive this. So obviously, every penny counts, and John needs to kind of really manage his fund very well, right? So he needs to kind of allocate a whatever the amount is, but he needs to kind of plan that thing right up. You cannot just kind of just go around splashing money everywhere. So he needs to kind of understand what is roughly a price of a house, right? Because this currently the 15 data points just kind of give you a very bad overview, right? They start from $200,000 and go all the way down there, right? So you really don't have an idea. But so idea is we need to understand at least what is the average price of that houses look right? So that's what he does. Exact thing that we talked about. He does and go there and calculates the average, right? So what is average? He decides to add all the prices and divide it by the total number of houses. So that is exactly what is called an average or a mean, right? So mean is basically nothing but sum of all observations by number of observations, right? So average of house prices. So average of house prices or mean, average, I don't know any other term, but yeah, let's stick with mean and average, right? So mean and average is nothing but sum of all observations for any given observation. It could be house prices, it could be heights of people in the class, it could be weights of people in the class, anything that is a continuous variable. A continuous variable is basically any variable that can assume any goddamn value on this earth. So height, weights are those, as compared to say color of buildings, right? Or probably I do not know, probably say, I have to think a lot more probably, but say the output of the outcome of if you roll a die, right? Die is 6-sided, so if you roll a die, there are 6 possible outcomes. So those are discrete variables. Discrete variables can only take up some specific values. Continuous variables can take up any goddamn value. A height can be 1.563335 whatever it could be, right? Not the same case for say roll of a die. Roll of a die can only be 1, 2, 3, 4, 5, 6. There could be 6 possible outcomes. So those are categorical variables or discrete variables. I'm sure you're familiar with it. If you're not, now I've spoken enough for you to be familiar with it. So in case it's a continuous variable, the averaging is very simple. You sum up all the variables divided by the number of observations. So John calculates the mean. He gets a value that is roughly $180,922. That's some value probably, right? That's some value that he has. That gives him some idea definitely. So now he has a decent idea of what he should be expecting, and at least a kind of reduces the panic stricken stress in him. Yeah, at least he kind of knows, right? So this is how you calculate this. You first import numpy as np, and then you do np.mean of the sales price. Remember, sales price is this column of that data frame, right? So we had read the data frame, and sales price was the column of that we have used. So that comes out to be 189021. So mathematically speaking, what John did was apply on a large scale to almost any number of observations one wants to consider to calculate the mean. So the mean is nothing but 1 by n summation I equals to 1 to n xi. So xi are basically nothing but the observations which starts from x1, x2, x3 to all the way to xn, right? So let's understand that. So your observations are basically nothing but this x1, x2, x3, x4, so on all the way till xn, right? So there are n observations, right? So what you do is to calculate average is x1 plus x2 plus dot all the way till xn divided by n, right? So this is your x bar mean. So mean is this, and you can basically represent this as 1 by n into summation of xi's. I equals to 1 to n. So this whole symbol that you're probably some of you would be seeing it for the first time is basically summation of xi. Basically means that x1 plus x2 plus x3 all the way to xn, right? So summation of xi is I equals to 1 to n, right? So that is, I think now you're probably familiar with this. So summation of say yi is basically nothing but I equals to say 0 to p is nothing but y0 plus y1 plus y2 y capital P, right? So that is the concept behind summation, this notation that you're seeing here. So once now that you know this is what is the mean. So number of n is number of houses that is researched, and x is the price of each house. So advantage of mean is that it takes every value into account, easy to calculate, and further analysis of calculation can be done easily as it is a unique value of a data set. So the basic point being, it's easy to calculate and it's easy to kind of interpret. So understanding John's approach. So John estimated that on average houses are sold for $180,222 throughout the Brooklyn. This number gave him an idea, but John was kind of skeptical about the method. Hey, this kind of came very easily, right? There's probably something wrong with that point. So John read about how mean is not a good approach, and then he said he kind of found that mean is often affected by outliers and median is a better statistic. What are these things? What are outliers? What is this thing called median, outlier, interquartile range? Sort of different things, right? So John does further research. So now he comes to this next topic that he wants to understand, which is median, interquartile range, and outliers. So median is nothing but the middle value of all the values arranged in an ascending order, which is basically to say median is basically the middle value in your entire distribution, right? So mean was basically where you take summation of all the values and divide it by n. Median is exactly the middle value. So if you have got 5 values, you arrange them in an ascending order, and the third value, whatever that value is your median, right? So it is a value where upper half of your data, so basically it divides your data into 50-50 quartiles, right? Sorry, 50-50%. So this is your entire data, and this is your median, right? So median is the value which exactly sits in your middle of the data, right? So this is your median. So if you're obviously, so how you calculate it is, if the number of values are odd, right? So if there are say 5 values or 5 values or 7 values, then it's very easy to calculate. There's only one middle value. If there is 5 values, then the third value is your median. If you have 7 values, then your fourth value is your median, right? Similarly, if you have 15 values, your 8th value is your middle value, right? So 8 value basically has 7 values before it and 7 values after it. So it's the exact middle value. So now let's understand that with an example. So say if you have given this examples 110, 90, 40, 50, 125, 65, 100, and you are asked to find median of them. How will you do it? Simple. You first thing while calculating median, just put them in an ascending order, right? So you do that 40, 50, 65. So now how many values are here? Let's count 1, 2, 3, 4, 5, 6, 7. So there are 7 values. So then the fourth value is the median, right? So the fourth value is 90. So 90 is our median, right? So that's the exact median. Now if you were to calculate mean, how would you do it? You would basically take 40 plus 50, 90, 90 plus 90, 110, 110 plus 110, 210 plus 100, 310 plus 125 plus 65. Oh, that's a lot of numbers, right? We'll calculate that. If you want, you're free to calculate. And can you just, once you calculate, you can see how that number, whatever that number comes out to be, how that is different from median, right? So median is basically nothing but the middlemost value, right? So that's exactly literally that's the definition of median, the middlemost value. And now what happens in case your n is basically even? So if there are say 8 values or in their case 10 values, then your median is nothing but there are 2 middle values, right? From whichever side you look from, depending on which side you're looking from. So base there are 2 middle values. So what you do is your median is basically nothing but the average of those 2 values. So your n by 2 and n by 2 plus 1th element, right? So if there are 8 elements, then the element which is average, then the value of average of 4th and 5th element is your median. If you have 10 elements, then your 5th and 6th are basically your middle values. So the average of 5th and 6th values would be your median. So in this particular case, this is already ordered in the ascending order, so you need to order in the ascending order. All you need to do is basically find out, and there are 12 values, so then 6th and 7th are the values that you are looking for. So average of 6th and 7th value is 25 and 25, so which is 25. So that's the whole point of median. Now what is the interquartile range? So an intuitive approach to IQR is a measure of variability based on dividing a dataset into quartiles. So how the way median basically divides datasets into 50-50 splits, a quartiles basically divide the data into 25-25 splits, right? So let's understand that very well in this particular case, right? So this is your median. Now what does quartiles do? Quartiles basically split your data into 4 parts, right? So this is your Q1, this is a Q2, this is a Q3, right? So there are three values, right? This is your first quartile, second quartile, third quartile. So this is your 25% of the data. This is the 25% of the data, 25% and then 25%, right? Now obviously you can realize that this value is basically the one that separates 50% and 50%. So this is your second quartile is nothing but your median, right? And then you have Q1 and Q3. So Q1 is your first quartile, Q3 is your third quartile, right? And the difference between them is basically nothing but IQR, interquartile range, right? So that's the idea of IQR. So, and obviously from this, there's an interesting concept that probably flows from here. So obviously quartiles divide your data into 4 parts. Now what about deciles? Deciles basically divide your data into 10 parts, right? So there would be decile 1, decile 2, so on, so forth, D3, D4, D5, so on and so forth, right? So this is your 10% data, 10, 10, 10, 10, right? So your D5 is basically nothing but your median, right? And then again you have your corresponding 4 more deciles, right? So this is another 10, 10. So you get the point, right? So deciles divide your data into 10%, right? So quartile, it divides into 25%, right? So 4 parts. Deciles divide into 10 parts. And finally we talk about percentile. Percentile is nothing but things that divide into 1 parts, right? So each part is, so it basically divides into 100 parts, right? So quartile divides into 4 parts, median divides into 2 parts, deciles divide into 2 parts, and percentile divides into 100 parts, right? So each part is 1%, 1%, 1%, right? So obviously 50th percentile is nothing but your median. P25 is your first quartile and P75 is your third quartile, right? So that's pretty awesome, right? So basically percentiles are, there are 100 percentiles, there are 99 percentiles, there are 3 quartiles, there are 9 deciles. So that's very easy to understand, right? So what we are doing out here. So it's basically different ways of splitting it. And interquartile range is basically nothing but the difference of Q3 and Q1. So this is exactly what we have already done, and you kind of understand this. So Q3 minus Q1 gives you interquartile range. So this is something that the plot that you see here is basically called a box and whisker plot diagram, representing any data, right? Any data can be represented in a whisker plot. How the whisker plot looks like is something that is interesting. So how this plot looks like is you have got the minimum value, right? And then you have got excluding outliers, right? So basically this is your Q, this is your median, the box is a middle value, the box is between Q1 and Q3. So this is your Q1, this is a Q3, and you have got median in the middle, and then you have got basically the maximum value excluding outliers and minimum values including outliers, right? So now the concept obviously that we need to understand is what is outliers. So outliers, so before we kind of talk about that, so let's first understand what is this diagram, then we can go back to understanding what are outliers. For now, let's understand this. This is the maximum value without outliers, this is the minimum value without outliers, and this box is basically between Q3 and Q1, and this is the median, right? So you can very easily understand this, right? So all your data points can be basically represented using this kind of a diagram, right? So this is so if you have like 15 values, you can basically plot them using this kind of a diagram, right? So there would be, say, probably 4 values which are outliers, 3 on the top and 1 in the below. So rest of the 11 plots basically lie something like this. So any number of data points you can have can be represented like this. So that's, now the point is, what are those maximum and minimum values, and what is more importantly, what is this thing called outliers, right? So outliers as per box and whisker plots is defined as any value that is Q3 plus 1.5 into IQR is greater than Q3 plus 1.5 into IQR, or Q1 minus 1.5 into IQR, right? So what you basically see here is, in this box and whisker plot, is this particular value is Q3 plus 1.5 into IQR, and this is Q1 minus 1.5 into IQR. So any value that basically falls above this is an outlier, any value that falls below it is an outlier, right? So that's the understanding of box and whisker plot, right? So it basically drives these black dots which are outliers, And outliers as per box and whisker plot is defined as this, right? Now outliers in a general concept can be defined in multiple ways. It can be defined in terms of, in this case it's defined in terms of IQR range, right? And it could be defined in multiple different ways. For example, it is defined in terms of number of standard deviations above median and all of I know probably you do not know what is the standard deviation, but there are definitely different ways, and we can probably talk about this in later lecture as well. But the understanding is this, that outlier as a concept is a big concept. It's a very broad concept. What we are just seeing here is one simple way of defining them, but that is definitely not the most hard and fast way of defining it. And in fact, outlier detection itself is a machine learning problem. So let's just take that in, and let's just for now understand this, that for now outliers can be definitely be understood as Q1 minus 1.5 into IQR or Q3 plus 1.5 into IQR. So now John also reads that outliers have an effect on the mean. So now let's visually understand what is the problem with having outliers. So outliers are basically these values which are extremely different from the rest of the values, right? So outliers, that's the concept behind outliers. That's a broad definition, and how you quantify them may change. You can use IQR, you can use different metrics, but the idea is that they are basically widely different values, right? And how we can how that affects mean is something we can see here, right? So these are 1, 2, 3, 4, 5, 6, 7. So yeah, there are probably 10. So there are 10 people in this class, and we are basically trying to calculate the average height of those people. Now you can see that most of the people around the class are around the height 2, 2.5, 3, 5.5, 4 and all of that, right? So there's a lot of people who are around this height of 2.5, 3, 3.5, 4.5, and there are these 2 people who are extremely tall, right? So majority of classes around this interval of say 2 to 5, right? 2 to 5 is majorly what your entire interval consists of. And now there are 2 outlier people who are extremely tall. You remember those people who used to sit in the back of the class, and people who used to be like, you always look at them, you're like, man, they are so tall, right? So those guys, there are 2 of them in this class. So the one is 16, the other is 20, right? And now obviously you can see what happens in case of mean, right? The mean is extremely skewed, right? Because you add all of these values up and you divide by 10, you would get your mean as 6. Whereas your median is 3.25, right? It is between 3, it's the average of 3 and 3.5. So that's a problem with mean. In case of mean, they tend to be extremely sensitive to outliers, because obviously you are adding all these values up, right? Whereas median is not concerned about any of the values. It's just concerned about what lies in the middle, right? Like the middlemost, once you arrange them in ascending order, it doesn't really care about the rest of the values, as it's basically just an average of 3 and 3.5, right? Because this is an even number of observation. Had it been odd, it would have just been the middlemost observation, right? So it doesn't care about the outlier values. Whatever value they have, it doesn't affect, right? As long as the middle value is like sane and normal, right? And the middle value would all likelihood be normal, right? So that is a problem with mean, and that's why we say that means is something that we do not want to use. So obviously you can see here, out of 8 out of 10 students basically scored below. Okay, so this is scores, these are not heights, so that's bad. Even they were height, you can basically see 8 of the students are basically very low, below 6, and you still see the mean is 6, right? Whereas taking a median is so much better. Median, you take 3.25, that represents a good estimate of how the class performed, right? Because that's exactly in the center of that range 2 to 5, right? Which kind of says that yeah, most of the people were around 3.25. That's fairly awesome. But when you say the average of the, in this case say the test marks, right, is 6, that hardly gives any idea about the things, right? Because 6 is way ahead. Only 8 people, out of those 8 people, only 2 people were actually better than 6, right? Rest of them were lower than 6. 8 of those people were actually lower than 6, and we still say that the average is 6. So that's the problem with averages. Averages kind of tell you a very disguised story. Don't trust averages ever. So obviously, therefore, to get rid of outliers, John now calculates the median, and also he plots a box and whisker diagram to get an idea of how it prices and see outliers. So what he does is he kind of tries to calculate the median. He calculates Q1, Q3, IQR and all of those things. And So the median is definitely $20,000 less, right? So our mean, if you remember, our mean was around 180,000 or something, right? 183,000, right? You see the median is 163,000. That is $20,000 less, right? Which probably says that, yeah, probably there are a lot of outlier values which are extremely high priced values, high priced houses, right? So there are probably some high priced houses which are outliers, and because we have that, our mean is basically shifted to the right, and that's why when we calculated median, the median price came out to be much lower, right? So that's something that you can definitely get an idea of. Okay, got. So now John does a box and whisker diagram. So obviously from this, that he can see that there definitely are clearly some outliers. So he calculates the number of outliers. So he says that outlier limit is first is Q1 minus 1.5 into IQR, and the upper outlier limit is Q3 plus 1.5 into IQR, and he gets those corresponding limits, right? And then he prints how many houses are actually below outliers and how many houses are above outliers, right? Above the upper outlier limit. So he sees that number of houses below lower outlier limit is 0. So there is no house on the lower side which is outlier, but there are a lot of houses, 61 houses, which are above outlier. Now if you go back to the box and whisker diagram, this is exactly the same thing that you see here, which is there are no outlier on this side of the thing, right? Below this particular lower box, the lower limit, there is no outlier. All the outliers that you see are on the above, on the higher side, right? So that's something that is clearly validated in this case as well. So what John did not do. So fair enough. So now he tends to think, hey, I think mean was bad, but median is so awesome, right? But then again, nothing is absolute awesome. So now all the box and whisker plot is a good method to find out an intuition and number of outliers. Another good way to find out is if we need to consider the median is by checking the skewness. So we know that median is more robust to outliers than the mean, thus giving us a better estimates of central tendency of our dataset. So, but what is skewness? Let's first build an idea of a skewness. To build an idea of skewness, we first build a histogram of the data.
Log on to GreyAtom's learning platform to unlock more free content. Subscribe to our channel and hit the bell icon for regular updates.